Hi everybody, welcome back to the CTO Demon channel. It's been a long time since I've done a video because James Su from Liverpool Hospital in Australia came and trained, and I was doing the videos mainly for him, and he's finished his 2 weeks of training here. We did 20 CTOs together, so he's gone back, and so now I'm trying to work on fluoroscopic 3D wiring and how to jailbreak it really. And I've tried a couple of videos. You might have watched those videos where sort of trying to explain. It's a process of me trying to work out how to work out this problem. And now I think I've come to somewhere that's a little bit better. So I'm doing another video on the new algorithm for 3D fluoroscopic wiring. Now, first of all, I will go through the algorithm in its general manner. So first, we start doing 3D fluoroscopic wiring really for the distal cap wiring. So when we're doing single wire antigrade escalation technique, the AWE, antigrade wire escalation, we get to around 15 to 10 millimeters away from the distal cap. That's when we, rather than just push the wire down and hope it goes into true lumen, we should stop and consider using 3D fluoroscopic wiring. The prerequisites for being able to do 3D fluoroscopic wiring is to have two views that are 90 degrees apart on the same segment of the coronary artery. And these two views have to be coaxial to the coronary artery. And we'll explain the views in another video sometime. But so we take two views that are 90 degrees apart. So if the mid RCA, that's the easiest one to learn from, it will be RAO and LAO 45. On these two views, we look which view the wire is further away from the distal true lumen. That we'll call the initial view, IV. The other view, 90 degrees away, would be the perpendicular view, PV. So if the wire is the same distance from the distal cap in both views, then it doesn't matter. Just pick either one as IV and the other one will be the PV. Go to the IV view and just turn the wire tip towards the CTO target. Now that's easy. We do that all the time when we're doing CTO PCI. We turn the wire towards the target in one view. That's no magic there. Then we go to the other view, PV view. And here is where we start making a difference. Instead of trying to turn the wire in the other view towards the target, what we do is we turn the wire very, very little bit, 2 degrees at a time, in one direction or the other, so that we straighten out the wire tip. So when you go to the other view, often the wire tip isn't entirely straight. It doesn't look at you straight like that. It's a little bit bent either this way or that way. So you just want to turn 1 or 2 degrees to try to straighten out the wire tip. Why are we doing this? This is because when we have a straight wire tip, then we can determine how many degrees we need to turn. And also, when we are doing this minor manipulation, what will happen is that we'll know which direction, when we turn the wire, we'll turn the wire tip towards the target and which direction is away. Because it could be either, depending on whether the wire is in front or behind the target. But if we turn the wire, we'll start knowing which direction the wire is going to turn towards the target. After we straighten it, then we need to make one decision. And the decision is how far is the wire from the distal cap compared to the initial view. So is it the same distance? So if the initial view and the PV are both around the same distance from the distal cap, that's called the same distance. If you go to the perpendicular view and it's half the distance to the distal cap compared to the initial view, that will be half distance. If it's a quarter distance, it's a quarter distance. The reason is the amount of degree of turn we put on the wire will depend on the distance, the difference of the distance, the ratio of the distance difference between the IV and the PV. Now, sometimes we're lucky, we turn to the PV view and the wire is slap bang in the middle of the vessel, in which case it's easy because now we're right in the middle. Once we straighten the wire tip, we just go back to the initial view and we try to puncture the distal cap by pushing the wire forward because it's already facing in the right direction. Next question is it on the right side or left side? Okay, either side doesn't really matter. What we do is after we straighten the wire tip, we turn the wire towards the target, and the number of degrees we turn depends on the ratio of the distance between the wire and the distal cap. So if in the PV, the distance is exactly the same as in the IV, then we turn 44 degrees. If in the PV, the wire is half the distance from the distal cap compared to the IV, then we turn 22 degrees. If it's a quarter distance, 11 degrees. If it's 3/4 distance, 30 degrees. So 11 degrees, 22 degrees, 33 degrees, 44 degrees. Those are the four, depending on what quarter the distance is compared to the IV. Now, there's a whole way to explain this, to explain why this method works, and I'll try to go into that, but probably another video. So after we turned it 44 degrees, you may find you got it wrong. And now the wire is facing away from the target rather towards the target. Don't worry, turn back 44 degrees and straighten the wire tip again and turn the other way 44 degrees. Then you'll be in the right place. Go back to the initial view and puncture. Now, why do we want to puncture in the initial view? The reason we want to puncture in the initial view is because in the initial view, that's the distance furthest from the wire to the target. And always puncturing from the furthest distance gives us the most accuracy. And we know this. When we do CTO, we always try to wire from the view that the wire looks most wrong in, not from the view that the wire looks right in. Because if you look at the wire that the view looks right in, you can't tell whether you're going in the right direction. So you should go to the view where the wire is furthest from the target to puncture. Now, when we puncture, you might find one of three things could happen. The wire could puncture straight into distal cap, beautiful, and get distal true lumen. We're fantastic. But the wire can sometimes slip off the distal cap. It can either slip off by going towards the near side of the wire. So if the wire is here, distal cap is here, we're going this way and not going across into distal cap. Or it can go towards the far side. You can try to hit the distal cap, but it slips off that way. Okay? The way to redirect the wire then is quite simple. You should avoid rotating the wire because the wire is already pointing in the right direction. If you are slipping off on this side, you should pull back more, because if you get more distance, there'll be more distance for your wire to get towards the target, and try to puncture again to puncture the tip of the distal cap. If you've gone past, you pull back until you're just above it, rotate 180 degrees where the wire tip is now going to point towards the target and push down. And you'll find that works quite well. So that basically is the algorithm. So I hope you enjoy the algorithm, and the next two videos is going to tell us why we think this algorithm works and how it works. We'll see you next time. Bye-bye.